In our last video, we began to catch on this idea called completing the square. It's a super famous just math trick in order to create a perfect square trinomial. Now, we're going to use that trick in order to solve equations. So, what we have over here is something very close, if I can get my pen working. What we have over here is something very close to a perfect square trinomial. If I added 16 to this side, so half of 8 we saw was 4, and you can square that and make 16. If you added a 16 here, you would have a perfect square trinomial, which we could then factor. Now, the problem is you can't just add a 16 just because you want to. So if you add 16 to one side, you have to add it to the other. So here they're doing the trick we saw in the last video, where we saw that if you cut this in half, you take a 4 and square it, you'd get a 16. Well, okay, that would be helpful, but we can't just add 16 to one side. We've got to do it to the other as well. Now, the reason this trick is so clever is because we can now turn this left side into x plus 4 squared. And this, we've already learned how to solve in an earlier video. We can just take the square root. We have the problem area is this square. It's isolated already. We can just take the square root. But if you take the square root of one side, you got to take the square root of the other, which leads us down here. And then we know how to just send that 4 to the other side and create the two possible solutions. Okay, so let me show you here. So this is set up. If you just recognize this, you have to just see this to realize you want to do this trick. But if I divide this in half, I'd get 4 or 2. I could square it and create a perfect square trinomial. So I'm going to do that. Half of 4 is 2. I'm going to square it. We'd get 4. Now I can't just add a number because I want to add a number. I have to do the same thing to the other side to keep this equation in balance. But if I do that, I now have something over here that's easily factored. And I've gotten to the point where the problem issue, the square, is isolated. I can just take the square root of both sides. Now, I'm not going to show it, but it's the square root of 9, and we know it's plus or minus. Okay, we send the 2 to the other side, and we get this. Now, if it's real numbers, if it's roots, you can leave it like that. But if it's real numbers, we're going to finish this. So negative 2 plus 3 would be 1. Negative 2 minus 3 would be negative 5. Okay, I'd love it if you pause the video and try this yourself, but I'll show you here. This would be set up. If we divide this by 2, get 5, and square it, we'll have our trick. So I'm going to add 25, but if I add it to one side, I've got to add it to the other. All right, now I did this because it's going to be very helpful, because if I factor it, I get this. Now over here, I'm just tidying that up. Now square root both sides. Okay, send that 5 over to the other side. And there's our two solutions. Okay, let's see. I don't know if they're doing anything different yet. I don't see anything different. Yeah, no, this is exactly the same. The only thing they've done here is now that it's a negative, but we saw it doesn't change completing the square. You take negative 6, divide that in half, it's negative 3, but you square it, it's still just positive 9. So the only thing that's changed is we're factoring a little differently. So if you take this, negative 2 squared is still plus 4. You can't just add something to one side without giving it to the other. So now we're going to factor this down. Okay, so the only thing the difference, if you factor perfect square trinomial where there's a negative in the middle, it's just you give it a negative sign. Okay, we're going to square root both sides, and we get r minus 2 equals plus or minus 4. R is 2 plus or minus 4. Okay, now this one you got to finish because you got real numbers, so we get r can be 6, or r can be negative 2. Okay, I would love it if you stop and try this one. So pause the video if you wanted to. So if I cut this in half, I get negative 5. Square that, I get 25. But you got to add it to both sides. So now I can factor this like this. Square root of both sides, I get t minus 5 equals plus or minus 6. T equals 5 plus or minus 6. So t must be either 11 or negative 1. Because I have 5 plus the 6, 5 minus the 6. Okay, I don't know where this one's going. Yeah, my guess is, the point here is that if you have this negative 21 over here, after you try to complete the square, it doesn't work. The only way we would be able to do this is something called complex numbers. I'm not sure where this textbook's going to go with this, but so for now, we completed the square and we square root both sides. You can't take the square root of negative 17. So we would have to stop for now. I'm not sure. I think there is something we can do. I just am not sure this textbook's going to do it. Okay, if I cut this in half, it'd be negative 5. Square that and get 25. Okay, well, let's add it to both sides. And you see what's going to happen. This is going to be negative 10 over here, so it's not going to work. So we can't square root this, at least we can at this point. So at this point you would say no solution. Alright, same thing's going to happen here. We're going to add 16 to this side to try to complete the square. But if we add 16 to that side, it's not going to make this a positive. We're still going to have a negative. So this is still going to be no solution. Okay, where are they going with this? Okay, so what's changed here? We do the same game. Cutting this in half, I get negative 9. Squaring it, I get 81. So I'm adding 81 to both sides. Yeah, they jumped really quickly, but they factored it down and already added it. I'm not sure where we skipped some steps, but we get down to this. So we square root both sides, we get here. Now the only difference is we've been having nice pretty numbers work out so far into the square roots, and this doesn't. The best we're going to do here is this, where we can simplify the radical, and then we send the 9 over to the other side, and we're going to get, this is where I would let you stay with this answer right here, because it's plus or minus the root, but this is fine too, where they're just showing you added 5 square root of 3 and you subtracted 5 square root of 3. Okay, let me work one all the way through here. So if I cut that in half, I get negative 8. So if I square that, I'm adding 64. Okay, now if we factor over here, we get x minus 8 squared. And then, okay, now we're going to take the square root of both sides. We get x minus 8 equals plus or minus the square root of 48. Now I'm going to tidy it up at the end here. I'm just going to send my 8 over and do it like we've been doing. So we've got this so far. Now let's break down 48. Oops, maybe. Okay, I'm doing the same thing where I'm breaking it down. I didn't see where we were going with this, but you've got a pair of 4s, so you can bring a 4 out of here. Yeah, 16 times 3 is, so it has a pair of 4s. You could bring a 4 out. So we've got 8 plus or minus 4 square root of 3. Now I would be happy with you leaving it there because of the root in there, but you could do like the book did. 8 plus this, 8 minus this, but that's good enough for me. Okay, we try this again. We cut 8 in half, that's 4. So we're going to square that and we're going to add 16 to both sides. So we get y plus 4 squared equals 27. Now we can square root both sides. We get y plus 4 equals plus or minus the square root of 27. Okay, whoops, I should have done like I did before. I'm going to send that 4 over. It'll be a negative 4. Okay, now we're done except for the square root of 27 can be simplified. It's made up of 9 and 3, so I'm going to do the fast approach because I see it, and you would get that. Okay, again, that's good enough for me. Okay, so what they're doing here is that we want to add a number We're going to cut the 10 in half and square it and get the 25. We could add that to both sides, but I think what they're going to do first, we had a 4 here that's really not very helpful. So what I would do, let's see if they're going to do the same thing. Yeah, they send them to the other side to start off with and turn them into 11. So they just paved the way for us to do completing the square. Do you see, like, we're going to need to add our number, so let's just get him out of the room and send him to the other side. Okay, so we cleaned it up in order to prepare the way for completing the square, and then it just becomes the same game it was. Divide 10 in half is 5, squared, it's 25. Got to add it to both sides, and then from that point everything is the same. So I'll work this one here. We have this 9 that's just kind of in the way, so we're going to send him to the other side. So subtract 9 from both sides. Okay, now we're ready to complete the square, where I'm going to divide the 4 in half, I get 2. Square that, I get 4. But I have to add it to both sides. Okay, now we're ready to factor. I get a plus 2 squared equals 25. Square root of both sides. So I'm going to jump ahead to that's plus or minus 5. I'm going to square root that. Remember, it's plus or minus. So I'm going to send negative 2 over to the other side. Okay, now these are whole numbers, real numbers. So I'm going to ask that you finish this one, and you would have negative 2 plus 5 is 3. Or a could be negative 7. I'm not sure why I put a plus 3 on there, but I did. Okay. Okay. I'm assuming this is more the same. We just have to get the 4 out. We're not quite ready to complete the square just yet. We need to tidy up. So I've sent the 4 to the other side. Okay, now we're ready to complete the square. Cut that in half, you get 4. Square it, you get 16. You do one side, you got to do it to the other. Okay, square root of both. Okay, these are real numbers, whole numbers, so I'm going to finish this one, and I would get 2 or negative 10. Remember, I'm just negative 4 plus 6, negative 4 minus 6, and those are my answers. Okay, all they're doing in this one is that we're definitely not set up. It's also going to be fractions, so let me show you. First of all, they set it up so we're in the right way. We don't want the end on the other side, or we can't complete the square. Now, unfortunately, I think the remainder of the ones, you can do this with nasty fractions and it will still work. So they sent the 3 into the other side. We've got this now. Now, half of 3, I think we had a few of these in the last lesson. Half of negative 3 is 3 halves. And so we're going to take negative 3 halves and square it, and we get 9/4. Yeah, I'm pretty sure we did this. Okay, so now this is not going to be much fun because we're dealing with fractions. But we just combine this on this side, square root of both sides, and we get all the way down to here. So again, not very much fun. Let me see if this is our last idea here. Not quite our last idea. We got a few more. So let me take you through one of these. I know this is getting pretty difficult. So we're going to get p squared minus 5p over here equals 9. I set this over just so I can be ready to complete the square. Now our trick is take half, but because it's 5, it's not going to work. We're going to get negative 5 over 2. Now we take half and we square it. So if you square negative 5 over 2, you square the top, square the bottom, it becomes 25 over 4. So that's the number that we want to add to both sides. Now I made 9 into 9 over 1 because I know I'm going to have to combine these. So I need a common denominator. I'm going to make it a 4. But if you do it to the bottom, you got to do it to the top. So I'm going to go ahead and factor this down over here. I know it's weird, but it's actually what the half number. Do you see we divided 5 by half? That's what it would be. That's why it's always going to work that way. Let's see. Okay, we've got 61 over here. Yeah. Okay, now we're going to square root both sides. We're going to get p minus 5 halves equals plus or minus the square root of 61. So now, from this point, it becomes the same process. I don't know. I can't think of anything that goes into 61. I think that's prime and cannot be reduced, but I could be wrong about that. Okay, so there we go. This is getting quite weird, but it's still doable. We're going to learn in our the next couple of videos an approach for these more difficult ones that's better than completing the square. But for now, we will press on. Okay, so we're going to take -7 and cut it in half. Then we have to square it. So we get 49 over 4. Okay, so I'm adding 49 over 4 to both sides. Okay, now this side I'm going to go ahead and factor. Now let's do 49 over 4. So I'm going to get at a common denominator. Can you see that I've jumped ahead a little bit? You see -3 could turn into -12 over 4. Okay, put that together. What do we got? 7/37. Yikes. Okay, now we're going to square root both sides. Now, remember our trick. I have a square root. I can turn it into the square root of the top and the square root of the bottom. So I can turn this into the square root of 37 over 2. Now I sent the -7 to the other side. It became a positive. And here's my solution. Okay, I'm hoping this one turns out to be easier. This is a variation. We haven't seen this. That this is factored and equals 9. But we can't just solve this. This is not the zero product property. The zero product property is only true if this right side is 0. And this is not the case. So what I'd have to do is FOIL this sucker out and then send the 9 over to make one of the rooms equal to 0. Or I think actually in this we'll be able to complete the square. Let me show you what I mean. So I FOIL this out and I get to here. Now in the past, what we saw, the only way we could do this was the zero product property, but this isn't going to factor. If I suppose, let me show you this so this makes some sense. Suppose I brought the 9 to the other side, I would have -24 equals 0. Well, actually, we could do this one by the zero product property. I didn't realize that. But so this would actually be the better way to do it. So they FOILed this out. I could bring that 9 over, and now I know that if I factor this side, I could find our two solutions. But they're asking us to do it by completing the square, so let's show that we'll get to the same place. So at this point, what they did, instead of going the zero product property, is they set the -15 to the other side, and I get 24. Okay, so we've sent that over. Now, let's complete the square. Half of 2 is 1/2, or half of 2 is 1. Square that, we're adding 1 to both sides. So now, if we factor it down, we get x plus 1 squared equals 25. And we get this. So when I was looking back here, here's what I was saying. I was like, well, yeah, you can do this. You could have factored it like that. Zero product property would say x is -6 or x is 4. Same thing. Okay, so I'm going to FOIL this out. I'm going to get c squared plus 8c minus 2c minus 16 equals 7. Okay, now they want us to do this. I don't know if the zero product would work, but we'll just do it the way they're asking us to do it. I'm going to prepare for completing the square by sending this to the other side. Yeah, no, I don't think it would work. Okay, so we send this over, we get 23. All right, so we take half of 6 now and square it. We're going to add 9. Do it to one side, you got to do it to the other. So now I've got c plus 3 squared equals 32. Square root both sides. Okay, 32 does break down. If you don't remember, just hit that old video. You'd get 4 square root of 2 there. And that would be acceptable because of the root. Okay, I would love it if you'd pause the video, try this on your own. I'm going to go for it here. I get d squared minus 7d plus 3d minus 21 equals 56. Okay, so we just tidied up and we really have this. Well, let's prepare to complete the square by adding 21 to both sides. So we're just going to get him out of the room. I've got d squared minus 4d now equals 77. Okay, now let's complete the square. Cut this in half, I get negative 2. Square it, I get 4. But if you add it to one side, you got to add it to the other. Square root both sides, I get d minus 2 equals plus or minus 9. D then is 2 plus or minus 9. So we're going to finish this one because it's real numbers here. I get 11 or negative 7. Okay, now that's not easy, I understand. But it's one super important math trick that's used through the rest of your math career. So hopefully that makes some sense, and I think we'll have one more video on it too in just a second.